All right, this is section 1.2, and we are doing everything to do with segments today. And then we're going to talk about this word called congruence. So first we're going to talk about the segment addition postulate. It has a lot of different names. I actually call it part plus part equals whole, or I refer to it as the PP whole equation. I know that sounds kind of funny, and you might think that's inappropriate, but if there's one thing you're going to learn or that you remember from this course, I bet it's that. By the end, we use this so often. We use it with segments. We use it with angles. We have a lot of different places where we put together parts and make whole things out of them. So the first thing we're talking about is if B is between A and C. So if B is between them, not in the middle, like not right in the middle of them, not dividing this in half, just somewhere in between them, then if I take A to B, that chunk, and I add it to B to C, that chunk, I will get the whole thing. So that's where the P equals whole comes from. If I take the two pieces and add it together, I will get the whole thing. And then it's kind of in reverse as well. If I take the two parts and put them together, then B is between A and C. So if it can be made up of pieces, then B's got to be in between them. Okay? So we're going to use that same idea the whole day, that kind of part whole thing. So in the diagram, find the length of GH. This is an F, by the way. Hopefully it looks right on yours. So F to H is 36. The whole thing is 36. 21 is for this part, and we're looking for this part. So we're going to put an X there. So it is part plus part equals the whole thing. 21 plus the X equals 36. Seems really dumb. I'm betting some of you probably looked at this and you went, oh, I'll just take 36, subtract 21, that'll give me what's left. That is what we're doing. So when I subtract that over, I'm going to get 15. That is the math behind it. But it's that practice of the part plus part equals whole thing that's going to help you once we get into some bigger problems. So there are two different kinds of notation. Geometry uses a lot of notation. When you have the segment above it, when you have the segment above it, that means that you're talking about the segment. When you don't have it above it, it means you're talking about the length. So this is like letters. This is numbers. So if we're talking about MN, we're talking about the physical length, or the physical like picture from M to N. And if we're talking about this kind of MN with no segment above it, we're talking about like how long is it? Like it's 4 feet long. So they just mean two different things when you see them. So here's the big word that we use a lot in geometry. It's called congruent. Line segments that have the same length are called congruent. We don't call them equal, we call them congruent because they are the same shape and size. If I had a 10 there and a 10 there, then you could say they are equal. And I know that's a super minor difference in your mind, but one of them is talking about the segment, the physical look of the segment, and the other one is talking about if I could measure it, how long is it? And then this is the symbol for congruent. So it's kind of like an equal sign, and then it's got a wave above it, and that is the symbol for congruent. It's not the same as equal. It means that they have the same size and shape as each other. So that makes them congruent. And then to mark that, like to show it on a picture, we add in that little vertical tick mark. So if we ever say two things are congruent, we kind of put that on there to tell everybody, hey, they're the same. I might not know how long they are. I don't know if they're 7 inches or 10 miles, but I know they're the same, whatever they end up being. So in the diagram, AB segment is congruent to CD segment. And I have to use segments because I don't know their actual length. If I knew that this one was 10 and this one was 10, then I could say AB equals CD because I know their number values. But they are different expressions for the information that you have. So this is talking about the physical shape of it. It is the same shape and size, and then this one is talking about if I actually know the numbers, how much is it, 10 inches, 10 feet, whatever. First example, we're trying to find the length because there's no segment. I want to know the length of UV. So this one right here. Oh, put a dot there. Somehow those didn't print. So they want to know how long is this physically. And so we are going to talk about finding the actual measure of it, like 4 feet or 6 inches. We're going to find its actual length. This one's kind of interesting. Like, they give me the whole thing from end to end, but they gave me a few more parts than normal. This one's got 3 parts. No big deal. Same thing happens. It is part plus part, and in this case, plus 1 more equals the whole. So it's just all the pieces add up to make the whole thing, no matter how many pieces you actually have. So 13 and 6 and 2x minus 18 equals, and then our whole is this thing. And we spent all that time working on solving and simplifying so that we could do these problems. So here we go. Fence down. We want to simplify first, so let's combine like terms. I've got a number, a number, a number. Oh, actually, I was circling those. Hold on, let me circle. So we're going to put those together. So I've got 13 and 6. Those are both positive, so I want to add those together. That'll make 19. And then the 18 is negative. So 13 plus 6 minus 18 gives me a 1. And then when we learned how to solve, we talked about how we want to move the smaller variable. So out of the 2 variables, I have a 2 and a 4, so I'm going to move the 2. So I'm going to subtract it. So these ones are gone, and the 1 just drops. And then this will end up being 2x minus 29. Subtraction comes before this multiplication here, so we'll add 29. So 2x equals 30. Sorry, squeezing onto the end of the paper here. The 2, this is multiplying, so I'm going to divide. X is 15. Now, what's tricky in geometry is we don't often stop at just what is x. We often need to plug it back in, and that's the case here. So it didn't say find x. We did that, but we have to find uv. So we're actually going to take 15 and we're going to plug it back in to just uv. This is the only part I care about. So I'm going to take 2x minus 18 and we're going to plug this in. Not set it equal, that's what our x is. So if x is 15, we're going to put a 15 right there. So 2 times 15 is 30, minus 18 is 12. One more. Says point C is between A and B on a segment. Use this information to find CB. That's the one we're after. And we should draw a picture. Okay, so C is between A and B. So I'm going to put an A here, a B here, and C is between them somewhere. And remember, I don't know if C is right in the middle, so don't put it there because otherwise you'll think it's in the middle. So I just kind of put it off to one side. AC is 13. AB is 12x minus 5, so it's the whole thing, goes the whole way. 12x minus 5. I'm going to put a W there, that's the whole. And then BC is 6x, so from here to here is 6x. So that's a part, this is a part, that was the whole thing. So part plus part equals whole thing. Fence it. We're going to get our x's on the same side. This one's smaller, so we're going to minus that over. They'll cancel, and the 13 will just drop. Subtraction comes first, so we're going to add that. And then this is multiply, so we're going to divide. In this problem, it also did not say solve for x. I mean, we definitely had to do that to keep going, but it wasn't where we need to stop. We're supposed to find BC or CB. That's why I kind of arrowed this so I wouldn't forget I got to come back. And BC is just supposed to be 6 times x. And we now know that x is 3. So in x's place, I'm going to put a 3, and that gives me 18. So lots to do today on congruent, using part plus part equals whole thing, PPW. And then even if you happen to have 3 parts, just make sure they're all on one side and they equal the whole thing.